It seems as if there is only one topic in the astronomical world at the moment, and that is the deployment of the revolutionary James Webb Space Telescope. However, in view of the countless insights that the complex instrument is expected to deliver in the near future, we must not forget one thing. The mission of Webb's scientific predecessor, Hubble, is also still in full swing. However, the more than 30 years that Hubble has now spent in space have left clear traces. Launched on April 24, 1990, the instruments of the 11.6-ton telescope sometimes show clear signs of wear. Accordingly, the failure of some components has already caused switching to backup systems. Despite this, Hubble will continue its research service for at least 4 more years. When the day finally comes that operations can no longer be maintained, the Space Telescope will be able to look back on an unprecedented success story. In today's video, we'd like to take a look at some literally profound Hubble images that remind us once again how much we really owe to Webb's precursor. Excited about the groundbreaking discoveries and spectacular displays in the cosmos? Then remember to subscribe to Simply Space and click the bell for regular updates on these exciting topics. By giving us a thumbs up, you're motivating us and showing that we can keep you engaged with the content of our videos. Planning the future. Good things take time. As early as 1946, Lyman Spitzer presented the first concept for a scientific telescope in Earth orbit. However, before the astrophysicist was engaged to design a large space telescope, another 2 decades were to pass. To bring these revolutionary plans to reality, the leaders of the National Academy of Sciences turned to NASA. Several feasibility studies and 4 orbiting astronomical observatory satellites later, the plans for Hubble's elaboration took concrete shape. However, in view of the costs of up to $500 million, the Budget Committee of the U.S. House of Representatives immediately rejected the idea. So, from then on, the task was to find ways to push down the price and make it possible to finance the groundbreaking project. ESRO was brought on board to fund the solar cells. In return, ESA's predecessor was given observation time and a scientific say. The main seal was also to be reduced from the original 9 feet to 7, so the new price tag of $200 million was finally blessed by Congress. Originally, the telescope named after Edwin Hubble, the discoverer of the expansion of the cosmos, was to set out on its research mission as early as 1983. However, internal problems and the terrible Challenger accident meant that the launch date had to be postponed by another 7 years. But still, the ambitious undertaking did not experience good fortune. An unexpected main mirror error led to the fact that the first Hubble photographs were practically useless. It would take 3 more years before the problem could be solved with the help of the CoStar mirror system. Astronomical success story. Given the decades of planning and the major complications that preceded Hubble's launch, one wonders why experts were so eager to place a technical research eye in Earth orbit. In fact, this choice of location has some significant advantages over Earth-based instruments. Space telescopes are not confronted with the filtering effect of the Earth's atmosphere. This unpleasant effect would otherwise affect certain wavelengths in the electromagnetic spectrum, and also disturbing air movements can be avoided in this way from the outset, before the technical device the size of a minibus left our blue home planet. It was given truly ambitious mission objectives. Just like Webb today, Hubble was to raise knowledge of the cosmos to a completely new level. With a resolution never before achieved, the instrument was to take a closer look at stars, planets, nebulae, black holes, and galaxies than ever before. A look at all the milestones Hubble achieved in the past 3 decades shows that it lived up to scientists' hopes brilliantly. Thanks to the study of the Cepheids, a group of stars whose brightness variations are strictly periodic, the cosmic distance scale has been recalibrated. In turn, the observation of distant supernovae should deepen our knowledge of the accelerated expansion of the universe. Moreover, thanks to Hubble, we know that a supermassive black hole lies dormant in nearly every galactic center, where it exerts a significant influence on the overall galactic evolution. Countless exoplanets were also tracked down and added to stellar maps as part of the mission. View into the depth. In addition, however, to the milestones just described, Hubble is also known for its legendary deep fields. According to the report, these complex images gave us an unprecedented glimpse into the gigantic depths of space. The first deep field was to be taken in December 1995, composed of 342 individual images. The Hubble Deep Field literally shows us the immense diversity of the universe. According to this impressive image, we can see more than 3,000 individual galaxies, some of these gravitationally bound collections of stars lying some 12 billion light-years away from us. In addition, we can see some bluish shimmering structures on this comparatively small section of the firmament. Although the individual structures have not been precisely categorized, it is reasonable to conclude that we are dealing with large cradles of stars, distant quasars, and possibly ancient white dwarfs. While the image leaves us in awe with all its sparkling objects, it was also of unparalleled value to the scientific community. Accordingly, the first deep field was able to detect a large number of galaxies with strong redshifts. This effect is again due to the constant expansion of the cosmos. As the expansion increases, so does the distance that gapes between us and these remote galaxies. In the same breath, the wavelength of the light of the star collections increases, the further they drift away from our home planet. In view of the positive echo, which the first Hubble Deep Field triggered both in the technical and in the media world, it's not surprising that Hubble let its technical view wander again into such remote areas shortly after the turn of the millennium. The so-called Hubble Ultra Deep Field, which was taken between September 2003 and January 2004, held the title of the deepest image of the cosmos for 8 years. In view of the 10,000 galaxies and structures that shine towards us in this image, however, we should not forget that the section captured on image covers just 1/40,000,000th of the entire starry sky. If Hubble wanted to capture the entire firmament in such a resolution, it would take 1,000,000 years. And this time too, the cosmic view into the depths turns out to be a scientific milestone. Accordingly, on the ultra-deep field, which is composed of 800 individual images, we see some of the faintest galaxies discovered to date. The light of some galaxies took a whopping 13 billion years before it reached our terrestrial eyes. In other words, this means that we see the corresponding collections of stars as they appeared just 800 million years after the Big Bang. However, even this glimpse into the cosmic depths was still not extreme enough for the experts. This changed only on September 25th, 2012, when the Hubble Extreme Deep Field entered the scientific stage. Over a period of 50 days, 2,000 individual exposures were taken. In the end, this once again produced the deepest image of the cosmos ever. Some of the 5,500 galaxies that we can marvel at here show themselves as they were 450 million years after the birth of the cosmos. Hubble's legacy. Those who have already been awestruck by the Hubble Deep Fields we have just seen will be even more amazed when they recall that Webb is up to 100 times more sensitive to electromagnetic radiation than its scientific predecessor. As is well known, Hubble's air has recently given pictorial proof of its extraordinary performance. Webb's first deep field gives us an authentic foretaste of all the remote secrets of the cosmos that will be uncovered in the coming years of research. In detail, we recognize the galaxy cluster SMAC 0723 in the image unveiled on July 11, 2022, captured on image by the near-infrared camera NIRCam. This area in the constellation Flying Fish is located about 4.6 billion light-years from our blue home planet. If some structures on this image appear unusually distorted to you, you have just caught a vivid impression of the gravitational lensing effect. In detail, this is the deflection of light by large masses. Consequently, the light from a more distant source is affected by an apparent object in front of it, the gravitational lens. To see how much the astronomical future differs from the past, it's worth taking a look at the direct comparison, because in fact, the corresponding region was also photographed by Hubble. Although we also recognize countless radiating structures in this image, in terms of colorfulness and detail, however, the Hubble image cannot keep up with Webb's groundbreaking features. Not only can we see the individual structures on the Webb image much better and sharper, in fact, we also see some objects here that Hubble could not capture at all due to its technical limitations. In fact, the James Webb Space Telescope was designed specifically for infrared astronomy. This means that the $10 billion instrument is capable of working from the red part of the visible light to the mid-infrared spectrum. In this way, Webb is expected to provide us with a direct glimpse into those cosmic mysteries that are currently the great unknown. And now it's time for your opinion. What do you think about the exciting mission of the Hubble Space Telescope and the impressive deep fields that were created during it? As always, write us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. Thanks for your interest, take care, and we'll see you next time.